Alright, in this video, this is video number 2 of the factoring tutorial series, and now we're going to look at finding a greatest common factor, but we're going to have some variables thrown into the mix. In part 1, we looked at just the numerical approach of finding greatest common factors, and I did mention 2 techniques to finding a greatest common factor when you have a set of numbers. We will still keep that same technique in mind, but sometimes we want to think about this a little bit faster. For example, number 1, 15x squared and 27x cubed. We want to find the greatest common factor. Now, depending on how your mental math is, you may look at 15 and 27 and you may be thinking 3. 3 is the greatest common factor. 3 is the biggest number that goes into 15 and also goes into 27. Just in case you forgot that though, if we take 5 times 3, that's the prime factorization of 15. That's how we break 15 up. And then we have x squared. That means times x times x. So this is the factorization of 15x squared broken up into all of its little itty bitty pieces. Let's do the same thing for 27x cubed. 27x cubed, if we take 3 times 3 times 3, that is going to give us 27. This is actually the prime factorization of 27. 3 times 3 is 9. Times 3 is 27. And then x cubed is going to be x times x times x. Now, when we look at these 2 factorizations of 15x squared and 27x cubed, we want to pull out the most they have in common. Therefore, our GCF, if we look, we have a 3 in common with both of them, so we have a 3. We also have an x in common with both of them, so we have an x. But we also have another x as well. So we have 3xx, which is the same thing as 3x squared. This is the most that they have in common. Now, we could not factor out an x cubed because the most they had in common were actually 2 of those x's, right? That's why we crossed out 2 x's in each group. With that in mind, let's move on to this one here. We have 3 pieces to find the greatest common factor of. Now, you could come and do the prime factorization of 100, do the prime factorization of 40, do the prime factorization of 80. However, use a little bit of mental math, and the GCF is not 10, it's actually 20. Pause the video here to see the prime factorization of 100, 40, and 80, and you will see that the GCF is 20. This is very similar to what we covered in part 1. 20 goes into 100 5 times, 20 goes into 40 2 times, and 20 goes into 80 4 times. So 20 is going to be part of our GCF, and I'm going to jump straight to the answer because I want you to think about how you can do this quickly. So the GCF, we have 20, that's the biggest number that will go into 100, 40, and 80. Now notice we have some A's, B's, and C's in all 3 of these terms as well. Now we want to find the most that they have in common, not the most number of A's necessarily. Sure, there's 3 A's here, A times A times A, but we don't have an A cubed here. As a matter of fact, all we have is 1A, and then over here we have 2. The most that they have in common is going to be just 1A. Think about that. A cubed is A times A times A. A single A here is a single A, and an A squared is a A times A. The most they have in common is just going to be 1A. So that's all that we can do with the variable A. Let's move on to B. How many B's do we have here? B squared, B cubed, and look over here, all we have is a single B. The most they have in common is a single B. Moving on to C's, we got C to the 5th, we got C squared, and we got C cubed. The most they have in common is going to be these 2 right here, so we have C squared. This is actually our GCF for those 3 terms. Now I'm going to take those 3 terms here, I'm going to copy and paste them. And I'm going to change one thing about this problem. I'm going to come back into this 100 and I'm going to put a D squared here. And I'm going to come to this last term here and I'm going to throw a D into this spot. Now, this is 3 different terms as compared to what we had up here. And you may be wondering, okay, what can we do with the D's? we can do nothing with the d's. And the reason why is that this term here does not have a d, so they don't have a d in common. We have to have it in common with all of our terms. And in this case, since this middle term here does not have a d in it, we cannot use a d in our GCF. Therefore, our GCF is still going to be the same thing. 20ab squared, just like I mentioned above. You have to bear this in mind. They have to all have it in common for you to call it a common factor. In part 3, we'll start throwing some expressions in here, some binomials and trinomials. And if you don't know what those are, I'll give you a refresher when we move on to video 3. And there you have it, finding a greatest common factor in an algebraic approach here, throwing some variables into the mix. And that's it for this video. I hope it helped.